Hi, welcome to the lesson on measures of spread. So at this point in the course we've been talking about measures of center, and it is very important to know where the middle is of a data set. Another thing that's important to know is how spread out it is. Are the data points all clustered right together, or are they really spread out pretty far? So that's what we're looking at in this lesson. Measures to determine how spread out the data is. We're going to look primarily at two measures of spread. We're going to look at the range and the standard deviation, starting with the range. The range is just calculated as the maximum data point minus the minimum data point. So in this example, we've got the biggest data point is 100, the smallest is 20. We just take the difference between them and we get 80. In this example, we've got our maximum is 73, our minimum is 67, so we subtract them, we get 6. It's not incorrect to say that the data ranges from, in this example, 67 to 73. But when they ask for the range, what they're looking for is for the difference between those two. And if we're comparing the two standard deviations here, the second one has a smaller range, so we would say that the first one is more spread out. Alright, so that's it for range. Now let's talk about the standard deviation. This is the most common measure of spread. If you think about, to figure out exactly what the standard deviation is actually saying, or actually telling you, if you pick apart that term, standard deviation, standard means typical, and deviation means distance. So the standard deviation really gives you the typical distance that observations are from the middle. Notation here is very important. So just like we had with the mean, we had x bar for the sample mean and mu for the population mean. We have a sample standard deviation, the symbol is S, and we have a population standard deviation, and the symbol is sigma. It's a lowercase Greek letter sigma. So S is a statistic, sigma is a parameter, and we're using S to estimate sigma. So we're using the sample standard deviation to estimate the population standard deviation. It is going to be very important later on that you know this notation. So if you're keeping up with note cards or something like that, which I would recommend that you do, this is a big one. Okay, so sample standard deviation is S, population standard deviation is sigma. You might see in an academic journal SD for the standard deviation. We'll just use S and sigma. Here's the formula, which looks messy, but it's not too bad. This just says we're going to take every data point, subtract the mean, square all of the results, and then take the sum of all of those, divide by the sample size minus 1, and then take the square root. So that's about 5 steps. So let's go through them step by step. So here was our data set. So the first thing we need to do is take every observation, subtract the mean, which means we need to know what the mean is. So if you add all those up and divide by 5, you get that the mean is 70. So it's just 67 plus 68 plus 70 plus 72 plus 73. Divide by 5, you get 70. So we're going to take every observation and we're going to subtract 70 from it. And then we're going to sum the result, square the result, I mean. Alright, so 67 minus 70 gives you negative 3. And when we square that, we get 9. Be careful of the negative sign here. So negative 3 squared is positive 9. Okay, and then 68 minus 70 gives you -2. And then when you square that, you get +4. Okay, when you do all of those and then take the sum, we get 26. All right, so if we go back to this formula, that means the top part of this formula here is 26. Now we need to divide by the sample size -1. Well, there were 5 observations in our sample. 5 minus 1 is 4. So we're going to take what we just calculated and divide it by 4. Alright, and then when we do that, that gives us 6.5, and our last step is to take the square root, and we get 2.5495. Alright, so I'm only putting one example in this lesson, but if you need any more examples, please let me know. I'll be glad to create some or find some, or come by my office. Just whatever you need, let me know that way. All right, but the steps were, we took every observation, we subtracted the mean, which in this case was 70. We squared all of those. So we squared all of those. We took the sum, we got 26, and then we divided by the sample size, so the number of observations in the sample, -1. And when we did that, we took the square root, and that gave us the sample standard deviation. Let me just mention quickly, this formula, I think, if you do this formula by hand a few times, at least for me it was the case, it helped me understand what standard deviation was. I almost hate to say this as a math teacher, but if we sort of suspend order of operations for just a minute, it's not quite like, it's not quite this, but it's pretty close. It's almost as if you see the squared here and the square root. Because of order of operations, they don't actually cancel each other out. But if they did, what we would be left with would be almost an average. So every x minus x bar is the distance between the observation and the mean. And then we'd be summing those up and dividing by almost the sample size. So this is very close to saying the average deviation. It's not quite the same because their order of operations are a thing, but I want you to understand that's why I'm asking you to do this by hand. There is a shortcut formula for the standard deviation, but it doesn't have that nice interpretation, and it's really not that much shorter. So I'm just gonna insist that you use this formula. I will, on the homework, ask you to do the standard deviation by hand once, and on the test I'll ask you to do it once. Otherwise you can get it under the descriptive statistics in StatCrunch. So if we compare the standard deviations, in the first one we would get 30.6186, and let me verify this for you. So the first data set, if we go to StatCrunch, that first data set was 20, 65, 80, 85, 100. So 20, 65, 80, 85, 100. So 20, 65, 80, 85, 100. So if we want to get the standard deviation for this data, type the data in, and then we go to Stat, Summary Stats, Columns. pick our column, and then you can just kind of make sure that it's giving you everything you want. Extra stuff is fine, doesn't really matter, as long as you have everything you need. And click compute. So this gives you the mean, the standard deviation, so 30.6186, which is what we said over here it was. That's where that came from. We point out to you, though, that the standard error is something different. So the standard error, we don't ever want to use that for anything yet. But it gives us the median, the range, the minimum, the maximum, and then some other things that we'll talk about in a bit. All right. But again, that was under stat, summary stats, columns. All right. So the variance comes up also from time to time, and I want to make sure we've talked about that briefly. The variance is just the square of the standard deviation. It doesn't really matter to us, but for statisticians, they like it because it has to do with the normal distribution. So you may see this in your book, so I just wanted to mention. You can get the variance by just squaring the standard deviation. So like we said, there is a population standard deviation as well. The formula would be similar if we wanted to do the population standard deviation. It would be just a little bit different. And I could tell you what it was, but I'm afraid it would just add confusion. So anytime I ever ask you to compute the standard deviation, it's going to be the sample standard deviation. All right. And before we leave, there is one more thing I wanted to show you real quick here, which is just something convenient that comes up in your MyStatLab homework. If you're ever doing a problem and you see a bunch of data, if there's this little double box right next to it, you can click there and just open it in StatCrunch. And you won't have to type in that data. Okay, so that should save you some time as you're doing some of your MyStatLab homework. All right, well,